Hello, today I will demo a distributed training application that I built from scratch. I am GPU poor and I want to train a ResNet 18 model on a large dataset. My little evil plan is to invite some friends over for a movie, ask them to install my library, and then train my model on their laptops. So let's jump right into the demo. In this system, there is a leader and a learner. So how it works is the learner registers itself with the leader, sends over its port and ID, and then gets the model from the leader and stores it as a local copy. Now, as a user, I tell this learner to start training. And that's the only manual part from a user side. Let's say we have two learners and I tell both of them to start training. What they do is they get different data batches for each learner from the leader, train on it, run backprop, and then take the gradients from that backprop and send it back to the leader. The leader accumulates these, which means it just averages them out, puts it on the model, runs the optimizer, sends the updated model state back to the learner. The learner loads this as the actual model it's going to use, runs the training on it, and then the loop keeps happening. That is basically how this model gets trained over time. Now, let's see this in action, right? So I'm going to first start the leader.py, then I'm going to start two learner.pys. And over here, you will see that both learners started the learner service, they registered their learner service, and they got the model. That's where we're at. Now let me manually start the training loop for the first learner. So now that I ran start train, you will notice that the training started on one learner only. So it started the training loop, got the data batches, trained the batch, accumulated the gradients, and sent the gradients, right? So you can see the acknowledgement that the leader got the gradients, but it hasn't gone on. The loop's not happening. Why is that? That's because the second learner is not running. So let's run the second learner as well, or start the training loop. I'm gonna start that. And what you're gonna notice is the second learner also gets the data batches. It trains the batch, accumulates the gradients, sends it over. And now the training loop is started. Both learners are getting their data batches, training on it, sending it back to the leader, and the leader is getting synced. So this is distributed training over multiple processes. In this case, it's processes, but it can actually work over the network as well. Now, with two learners, you're processing twice the amount of data in the same amount of time. There are some network overheads, but essentially it's the same amount of time. So something similar to this happens in federated learning, where edge devices are all over the place. And this way, you're basically getting data from different sources, processing it on different sources, but not touching the raw data on those sources. Thank you.